Today is a very important milestone in our project Koorma that has been going on for months now. Today we have the remote and the chassis running on independent mode with its own lithium ferrophosphate battery, and it has reached a fantastic milestone where the mobility aspects are completely taken care of. Next onwards we'll change this entire look and feel on the top. It will be IP compliant, sealed, and we'll start putting payloads on different payloads on this. Okay, so let me explain the remote first. So this remote has a power switch here and a USB charging port here. It's very simple lightweight remote, and there are different buttons and a joystick control here. Okay, and it is almost self-explanatory. There's a power indicator, there's a communication link up indicator, there's a brakes indicator, there's a robot battery reserve and low indicator, and the remote battery is charging or remote battery is low indicator. Apart from that, we have manual brakes. This makes a ultra slow mode, on axis turn mode, and there is a hazard indicator which will switch on the lights on the bot eventually. There is also an auto brake mode where as soon as you start driving the joystick, it will engage brakes on its own, the vehicle. This is required only in very special terrains or very steep places where you are driving, and in case you lose control on the joystick, the robot does not tumble or roll over. There is a headlight switch, there is a low speed, high speed mode apart from the ultra low speed here. Now I'll explain the chassis features. Okay, so it has got two 10-inch wheels with a disc brake on either side, powerful 150 watt with geared motors, and two wheel casters to support it in the front and the back. Full aluminum chassis, IP compliant, and the remote communication is through a 433 MHz RF link between the remote and this. Eventually all this will be sealed, and the range is close to, remote control range is close to about half a kilometer. Now I will move the vehicle forward by pushing this joystick, but you can see first thing it did was disengage the brakes and it has started running, and I can control this vehicle's direction through my joystick control here. It can handle rough terrains, and it can also be highly mobile platform. Now I can bring it back, turn left, turn right while coming back, and I can change the speeds. Now one of the special features of the mobility here is I have a high mobility mode where I press this on axis button and do a full left. You can see it does a on axis rotation. It doesn't change the spot. Wherever it is, it can turn either left or right. And if I keep holding this vehicle, holding this slow mode button and driving it, it drives in a very slow movement. It can do negotiation, a very fine negotiation it can do. And this chassis is capable of carrying close to 70 kg to 100 kg payloads depending on the application. Okay, and now I have a high speed mode. You can see how fast this whole robot moves. This is a high speed mode, and there is a low speed, regular speed mode. This is a regular low speed mode I am driving it in. This is a low speed mode that I am driving the vehicle in. See, it can go straight. And once I hit the brake, the vehicle engages brake, my brake indicator starts blinking here. For safety's sake, until I leave the joystick and remove it, it does not. And disengaging brake, there is no button. As soon as you start driving, the vehicle disengages and starts moving. So one of the first payloads that we are planning to integrate with this vehicle is this weed cutter. So this can cut very tall weeds and clear up roadside weed growth and other things. Same thing will be mounted on our vehicle. This is one of the first payloads we are going to integrate to our vehicle.